and all. And today we are going to discuss about theory of inference. The theory of inference in DM&GT refers to the study of logical connectives or systems and methods for deriving conclusions from the given premises. So the theory is associated with rules of inference. Such rules is known as theory of inference. So what is premise? So a premise is defined as a set of individual variables and a combination of variables of some connectives that variables takes as truth value true only. That means a premise is a statement or proposition that is assumed to be true. Okay, a premise is a statement or proposition that is assumed to be true. That is defined. A premise is defined as a set of individual variables and combination of variables of some connectives that variables takes as truth value true only. So valid argument. So valid argument is defined as set of premises and its conclusion must be true. So if the conclusion and premises are false, then that argument are said to be invalid. So methods for finding valid arguments. Methods for finding valid arguments. There are 5 methods: validity using truth table, rules of inference, rule of conditional proof, indirect method of proof, consistency of premises. The first method, validity using truth table. In this method, we first construct a truth table for given premises and then compare premises and conclusion. Then both are true, the given argument is said to be valid. Otherwise, we said to be invalid. Okay. First, for example, test the validity of the following argument. Here, given premises are P implication Q, P, followed by the conclusion Q. So first we construct truth table for the given premises. Here, given premises have two variables. So we have 4 truth values for each variable. So P has truth values true, true, false, false. Q has truth value true, false, true, false. P implication Q. When P is true, then Q is false. P implication Q is false. Otherwise, it is true. Okay. So the truth values for P implication Q is true, false, true, true. So here given P implication Q is first hypothesis and P is second hypothesis, Q is conclusion followed by the conclusion Q. So now we compare the truth values for both premises. So H1 is true in 3 cases. So in these 3 cases, second premise is true in 2 cases. Okay. In these 2 cases, conclusion follows true in first case. So in first case, both premises are true and also followed by the conclusion is also true. So we conclude that the given argument is true. So the given argument is valid. So in the first row, H1 and H2, hypothesis 1 and hypothesis 2, both are true. In the corresponding row, the conclusion C is also true. Hence, we write P implication Q, comma P followed by the conclusion Q is a valid argument. Second problem, test the validity of the following argument. In this, it is given first hypothesis P implication Q and second one negation P followed by the conclusion Q. So here also two propositions. So we construct truth table for P, Q and hypothesis 1, hypothesis 2 followed by the conclusion Q. Okay. So truth values of P are true, true, false, false. Q is true, false, true, false. And negation. The rule of negation is true becomes false, false becomes true. So true, true, false, 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 true, true. The rule of implication is when P is true and Q is false, then the implication will be false. So in second case, the truth value is false. In other cases, truth values are true. So now we compare. Hypothesis 1 is true in 3 cases. In these cases, hypothesis 2 is true in third case and fourth cases. In corresponding cases, the conclusion C is true in third case but false in fourth case. So we conclude that the argument is invalid because in here in one case it is true conclusion and another case it is false. It is not a valid argument. So we concluded that the given argument is invalid. The given argument is invalid because in the fourth row both true hypotheses are true but the conclusion is false. So the given premises are invalid. Second method is rules of inference. So consider a set of propositions P1, P2, P3 and so on Pn and the proposition C. Then the compound proposition is P1 and P2 and P3 and so on and Pn. So conjunction of P1, P2, P3 and Pn followed by the conclusion C is called an argument. Okay. So here P1, P2, P3 these are all called premises and C is called the conclusion for the given argument. So the above argument can be written as P1, P2 and so on Pn followed by the conclusion C. Some rules of inference. Here rule P. A premises may be introduced at any point in the derivation. That is given premise. A premises may be introduced at any point in the derivation. Simply we say that this is a given premise. Given premise is said to be rule P. A formula S may be introduced in a derivation if S is tautologically implied by one or more of the preceding formulas in the derivation. So this is derived rule in the derivation is rule T. Derived premise is said to be rule T. Given premise is said to be rule P. Okay. Rules of inference. Some rules are rule of conjunctive simplification. So P and Q followed by the conclusion P. So this can be written as P and Q is tautologically implied by P. So rule of disjunctive simplification, P followed by the PRQ by the conclusion PRQ. This can be written as P tautologically implies PRQ. This rule is called disjunctive simplification. So rule of syllogism. The rule of syllogism says P implication Q and Q implication R, then the conclusion follows P implication R. This can be right P conjunction of P implication Q, Q implication R, tautologically implied by P implication R. So rule of modus ponens. P implication Q followed by the conclusion Q. The conjunction of P implication Q tautologically implies Q. This rule is called rule of modus ponens. Rule of modus tollens. So in this rule, P implication Q, negation Q, derive the conclusion negation P. So conjunction of P implication Q, negation Q tautologically implies negation P. This rule is called modus tollens. So rule of disjunctive syllogism. PRQ negation P, therefore Q. So Q is the conclusion. This can be written conjunction of PRQ negation P tautologically implies Q. So for example, test the validity of the following. So if Sachin hits a century, then he gets a free car. Sachin does not get a free car. Therefore, Sachin has not hit a century. If Sachin hits a century, then he gets a free car. Sachin does not get a free car. Therefore, Sachin has not hit a century. This is given argument. Okay. In this argument, we have two propositions. Let it be PQ. So the propositions are Sachin hit a century and Q proposition B, he gets a free car. So then the given premises are in logical form is if then. The connective word is if then. That means we write in logical form P implication Q. P implication Q. In second premise, Sachin does not get a free car. Not. Here it is given not. Not means negation. So we write this premise in logical form negation P. Therefore means a conclusion follows. The conclusion is Sachin has not hit a century. So we write negation P. So first premise is P implication Q. Second premise is negation Q. The conclusion will be negation P. So in view of rule of modus tollens, the given argument is said to be valid. Okay. So first we write given propositions from the argument and then we write logical form of given argument and then we apply known rule of inference. Okay. So finally we conclude that in view of rule of modus tollens, the given argument is valid. Second example, if Rahul hit a century, then India will win the World Cup. And second premise is Rahul hits a century. Therefore, India will win the World Cup. So we identify the propositions and connective word if then. So the here propositions are Rahul hits a century and India will win the World Cup. Okay. So then we write the given argument in logical form P implication Q and P. So second one, Rahul hits a century. So therefore, India will win the World Cup. The conclusion is Q. So P implication Q, P, which gives Q. In view of modus ponens, the given argument is said to be valid. Okay. So another one, derive R from the premises P, P implication Q, Q implication R. Here P implication Q, Q implication R given premises, and we by using these premises we derive R. Okay. So if we derive R from these premises, the given argument is valid. So we have to show that conjunction of these three premises tautologically implied by R. So here we take any premise is our choice. Okay. So I introduce P. This is given premise. So we write it as rule P. So we take the premise pre. This is rule P. Rule P means we introduce the given premise at any point in our derivation. That is our choice. Okay. And second premise is P implication Q. So this is also given premise. So this is rule P. From these two premises, we derive by the rule of P implication Q, which derive tautologically implies Q. By applying this rule from these two steps, we derive a premise Q. Okay. So we derive Q. So this is derived premise. So this is called rule T, from which rule we apply P implication Q is tautologically implies Q. Okay. So and then we introduce the remaining premise Q implication R. So this is given premise. This is rule P. From 3 and 4 formulas by the rule of P implication Q implies Q. By applying this rule, we derive R. So this is derived premise. So rule T. Hence, the given premises are valid. Okay. So next one, show that S or R tautologically implied by P R Q, P implication R, Q implication S. So the given premises are P R Q, P implication R, Q implication S, followed by the conclusion S R R. Okay. We have to show that conjunction of P R Q, P implication R, Q implication S tautologically implies yes or R. So we take any premise in our derivation. This is our choice. Okay. First we take the premise P R Q. This is given premise. A given premise is said to be rule P. Okay. By the known tautological implication, P implication Q, which is equivalent to negation P R Q. So by this equivalent formula, P R Q, which is equivalent to negation P implication Q. We apply this equivalent formula, we derive the rule negation P implication Q. So this is derived formula. So it is rule T. From first formula we derive negation P implication Q. So rule T from first formula by applying this equivalent formula. Okay. Again we take another given premise, that is 3 P implication R. This is given premise, so we write it as rule P. So by the known equivalent formula P implication Q, which is equivalent to negation Q implication negation P, we apply for third step. So negation R implication negation P. So this is derived premise, so we write it as rule T. So for this rule, again we apply rule of syllogism. P implication R, P implication Q, Q implication R, which gives P implication R. So here we apply syllogism for 4 and second formula, 4 and second formula. So this is P implication Q, Q implication R, which derive negation R implication Q by the rule of syllogism. So this is derived formula, so we write it as rule T from second and fourth formula. And then we introduce the given premise Q implication yes. So this is given premise, so we write it as rule P. So for this formula we apply rule of syllogism for 5 and 6 formulas, 5 and 6. So negation R implication Q, Q implication S. This is of the form P implication Q, Q implication R, which derive negation R implication S by the rule of syllogism. So this is derived premise. So we write it as rule T. Okay. So by the equivalent formula, we write negation R implication S. We derive RRS by this equivalent formula. Negation P implication Q is equivalent to tautologically implies PRQ. We apply this tautological implication to seventh formula. We derive RRS. This is derived premise, so we write it as rule T. By the commutative law, we write SRR. This is derived formula, so rule T by applying commutative law. So hence the given argument is valid. This is the required conclusion for the given premises. Okay. So next third method is rule of conditional proof. Rule of conditional proof. So rule CP. If we can derive S from R and a set of premises, then the statement R implication S can be derived from a set of premises alone. So rule CP is generally used if the conclusion is of the form R implication S. The rule CP is generally used if the conclusion is of the form R implication S. In such cases, R is taken as an additional premise and S is derived from the given premises and R. So first problem, establish the validity of the following conditional by conditional proof. So the given premises are, the given argument is P and P implication negation Q and R and S tautologically implies Q implication R. So here P implication negation Q, R and S are given premises and the conclusion is Q implication R. By applying rules of inference, we derive this argument. So we can take the given premises at any point in the derivation. So in first step, I take the formula Q. So this is consider formula. So this is called rule CP. So in second step, I introduced the given premise P. So it is given premise. So we write it as rule P. By the rule of PQ tautologically implies P and Q. By this rule, we derive P and Q from second formula. So this is derived formula. So we write it as rule T. From 1 and 2 formulas, we derive the formula P and Q. By the rule PQ tautologically implies P and Q. By the De Morgan's law, we write negation of negation P or negation Q. So rule T, we apply De Morgan's law for third formula and we derive the formula negation of negation P or negation Q. This is derived formula. So we write it as rule T. So here we introduce another given premise P implication negation Q or R and S. So this is rule P. From fourth formula, negation P or Q is equivalent to P implication Q. By applying this rule, we derive negation P implication negation Q. So in place of P, negation P, in place of Q, negation Q. So negation of P implication negation Q. So from 5 and 6 formulas, we apply PRQ negation P. By this rule, we derive Q. So in place of Q, we have R and S. So this is derived formula. We write the rule T from the steps 5 and 6. Okay. So next we derive R from 7th step. By the rule P and Q tautologically implies Q. So by this rule we derive R from R and S. So derived premise, so we write it as rule T. So from 1 and 8, we finally derive Q implication R Rule T, by the rule P comma Q tautologically implies P implication Q. Hence, the given argument is valid. We finally derive the conclusion Q implication R from the given premises and rule CP. So, hence the given argument is valid. Thank you.